Hello and welcome, and in this video we will be solving three variable systems of equations. We're finally here, okay? Now, I know in previous videos I was like, yo, solving by substitution is the best. Not so much with three variable systems, okay? 99% of the time, I will be using elimination with three variable systems. Substitution is once again completely viable. It's just that with three variable systems, it gets so messy sometimes. So I will be covering this using elimination, all right? And fair warning, if you haven't watched the previous videos on solving two variable systems and you're here, you're outside your mind, okay? I will put a link in the description for those below because all of those concepts is what we are using here now for three variable systems. Another warning. This can get very messy very quickly, okay? And if you make a simple little adding or subtracting mistake, it's gonna blow up your whole problem and you're gonna be absolutely miserable trying to figure out where you went wrong. So organization and being as detailed and meticulous as possible is absolutely crucial with these. I don't mean to scare you, but these can get pretty hairy, all right? Now, when we're solving a three variable system using elimination, it's going to be a little bit more time consuming. Now, normally when we use elimination with a two variable system, we eliminate a variable because then we're left with one variable that we can solve for. The only problem is here we have a whole extra variable, so we're going to do a whole nother set of elimination, okay? So the first step is to pick on a variable to eliminate twice using two different combinations of equations, okay? Now, if I'm looking at this three variable system, I'm looking at the x's and I'm going, okay, 2, 4, and 6, that would probably be pretty easy to cancel out, but the y's might even be easier. Not necessarily, they're kind of the same, but I'm gonna go ahead and focus on canceling out the y's just because I noticed that one of them is a variable, or excuse me, a coefficient of -1, and I can take care of that pretty quickly, okay? Now, I'm going to go ahead and use, say, the first and third equation. I'm going to cancel out the y's. And to do that, I'm going to have to multiply the second equation through by +2, okay? So I'm going to go ahead and do that now. And I'm going to rewrite them on top of one another for organizational purposes. All right, so I went ahead and multiplied the second equation through by 2, and I'm just going to double check to make sure I did it right, because like I said, it sucks when you make a little mistake in these. So 12x, -2y, 8z, -2. Yep, everything looks right, and I went ahead and rewrote the first equation just to say organize. And now when I add these together, I'm going to get 16x, the y's cancel like I wanted them to, plus 11z is equal to -1, okay? What do? Well, I can't actually solve for x or z, so I'm actually going to have to use another set of equations to cancel out y again, okay? So I can't use the first and third, so I'm going to use the second and third. And to do that, I'm now going to have to actually multiply this equation through by, let's see, -3. So I have a -3y and a +3y. So I'm going to go ahead and do that now. All right, so I went ahead and I just rewrote the second equation just to say organize, and I now multiply this equation through by -3, so I got -18x, +3y, -12z, and +3, because now when I add these equations together, I'm going to get -16x, the y's cancel, that's what I wanted to happen, -7z is equal to -11, okay? Now, this is where our next step comes in. And now I have a whole new system. I'm going to rewrite these on top of one another. So I have a new system. I have 16x plus 11z is equal to -1. And I also have -16x minus 7z is equal to -11, okay? So now I have this new, but notice, two variable system. Now it's back to the previous videos. Now it's back to Algebra 1. I can use either substitution or elimination to solve this two variable system. And that is honestly most of the battle. Most of the battle is literally just getting to one answer, all right? So if you notice here, we actually got like crazy lucky. And if I just add these two equations together, the x's are going to end up canceling. So that's exactly what I'm going to do. I'm going to add these two equations together, and I have 16x plus negative 16x. Those cancel out just by luck. If they didn't, just use elimination or substitution like we did in the previous couple videos. But they do cancel out, luckily. So we are left with 4z is equal to negative 12. And now I can solve for z. Z is going to be equal to negative 3. So I have a variable. Big whoop. I need to know the other two. Well, once you have one variable, it's actually fairly straightforward. Now I just have to work backwards. I have to plug this into any of these two equations. Because if I plug z into either of these two equations, now I'm only going to have x. And then I can solve for x. And then once I have two of the variables, in this problem x and z, I can plug them into one of the original equations and solve for y. So I'm going to go ahead and plug in z into, let's say, this equation. It doesn't matter which one, but I'm going to plug it in for this equation. So when I do that, I get negative 16x minus 7z, and z is negative 3, is equal to negative 11. And this is going to become negative 16x plus 21 is equal to negative 11. Now I'm going to go ahead and move the 21 over. So I'm going to have negative 16x is equal to, that's going to be negative 32, right? Yep. And now x is equal to positive 2. So I have x is 2, I have z is negative 3. Now I can take both of these and substitute them into any of the original three equations, all right? And that's going to leave me with just y. So I'm going to go ahead and take these, and I'm going to substitute them into the first equation. So I'm going to take that negative 3, substitute it in for z. I'm going to take this positive 2, I'm going to substitute that in for x, all right? So that is going to leave me with 4x, and x is 2. X is 2. Plus 2y. I don't know y yet. That's what I'm trying to find. Plus 3z. I have z is negative 3 is equal to 1. And now this is the easiest part of the whole system, okay? Of the whole series of kind of elimination and substitution we had to do. Now I just solve for the last variable. So I'm going to do 4 times 2, which I hope you know is 8, plus 2y. 3 times negative 3 is negative 9, is equal to 1. I can now combine some like terms. I'm going to get 2y minus 1 is equal to 1. That's going to give me 2y is equal to 2, which gets me y is 1, okay? And that is going to be part of our solution. That is kind of our solution, but now I want to talk about what a solution here. What is a solution to a 3-variable system? Well, 2-variable system, remember, is where 2 lines were intersecting one another. With 3-variable systems, we're actually talking about 3 planes intersecting one another. Not just a line, an entire coordinate plane, okay? And since it's 3 variables, our answer isn't going to be an ordered pair. It's actually going to be an ordered triple, okay? So our final answer is going to be x, y, z, with x being 2, y being 1, and z being negative 3, all right? And that would end up being our overall solution. I know this is time consuming. I know this seems very daunting, but I promise you it just takes a lot of practice. First step, cancel the same variable out twice, okay? So I use 2 different sets of equations. I use the first and third equation. I use the second and third equation. I canceled out y in both of those because that left me with a new system in just 2 variables, x and z in this case, which then allowed me to cancel out another variable and solve for the third one, and then you just work your way back, okay? So it seems very daunting, but I promise you, just a little bit of practice is going to go a long way here. So I'm going to go ahead and do one more problem here. And then in the next video, we'll probably cover some applications of this because there's actually quite a few applications of 3-variable systems. But let's go ahead and cover one more problem. All right, so we have a new 3 variable system here. Now remember, I like to solve 3 variable systems using elimination. I do differ a little bit with 2 variable systems. I like substitution, but with 3 variable, I'm definitely going elimination. So I'm looking at this system and I'm thinking, all right, what would be the easiest variable to eliminate? And to be honest with you, a case can be made for x, y, and z. All of them have an equation where the coefficient is just 1 or -1, which makes it very, very easy to cancel pretty much any of them out using elimination. I am going to once again cancel out y though. The reason is because if I look at the first and third equation, they're already opposite coefficients. One of them is 1 and the other is -1. So I can just add those two together actually, and they're going to cancel out. So I'm going to go ahead and do that. So I'm going to rewrite them just for organization purposes. So now notice, when I add these two equations together, so I just rewrote the first and third equation, when I add those two together, the y's are going to cancel out immediately. I don't even need to alter either of the equations. It's very nice. So when I add these two together, I'm going to get 8x, 0y, because the y's cancel, plus 6z is equal to 44, okay? So that's my first kind of set of equations where I canceled out y. So now I'm gonna have to use a different combination. So I used the first and third, so I can now either use the first and second equations or the second and third equations. I can't do the first and third equation again. And I'm gonna go ahead and actually do the second and third, all right? And for that one, I have 2y here, which means I want this one to be -2y. So to do that, I can just multiply this one through by a +2. So I'm going to go ahead and do that. All right, so I went ahead and just rewrote the second equation, but I multiplied this third equation through by 2, okay? Now left me with 10x, -2y, 10z equals 60. So now when I add these two together, I'm going to get 9x. The y's cancel once again like I want, plus 7z, plus 7z is equal to 51, okay? And now I have a new system. I have 8x plus 6z is equal to 44, and I also have 9x plus 7z is equal to 51. And now I have a 2 variable system that I can solve using elimination or substitution. Now, there's really not a best answer here. You can use substitution or elimination. Either way, though, is going to get a little messy. So I'm actually going to go ahead and use elimination, and I'm going to cancel out the z's, okay? You could cancel out the x's, but I'm going to cancel out the z's. The least common multiple here is actually going to be 42, so I'm going to end up with some pretty big numbers. So if I multiply this top equation here through by a +7, that's going to make a +42z, which means I can multiply the second equation through by a -6 to make that a -42z. All right, now I'm going to get some pretty big numbers, so let me get my calculator and I'll kind of speed this up and show you what this system is going to end up looking like. All right, so I went ahead and altered both of these equations, and now as we can see, we have the z's are going to end up canceling out. One of these is 42, one of these is -42, so when I add these two together, they're going to end up canceling out. So once I add these together, this is going to become 2x, the z's cancel, is equal to 2, and that gets me the nice small answer that x is equal to 1, okay? Whew, not that big of a number, all right? Now remember, from here, we have to go backwards. So I'm going to have to plug this in to either of these two equations and then solve for z and then go backwards again. So I'm going to go ahead and plug this in for x here. So that's going to get me 8x, and I found x is the nice small number of 1, thank God. Plus 6z is equal to 44, and now I'm going to end up getting 8 plus 6z is equal to 44, which gets me 6z is equal to 36, so z is equal to 6. So not too bad of a number. All right, so z is equal to 6. Now that I have x, I have z. I can plug these into one of the original 3 equations. Finally get y, okay? So remember, it doesn't matter what equation you plug it into. I'm going to plug it into this first equation here. So I'm going to plug z in here. I'm going to plug x in here, and then I'm going to finally solve for y, okay? So this is going to get me 3x, and I get x is 1 plus y plus z, and z is 6, is equal to 14. And now I can go ahead and solve for y. So I get 3 plus y plus 6 is equal to 14. That gets me y plus 9 is equal to 14. And that gets me y is equal to 5, all right? And there we have it. We have our final answer. That's going to be an ordered triple, remember, of 1, 5, 6. And that would be our final answer. And that is solving systems of 3 variable linear equations. There's probably a nicer way of saying that. Solving 3 variable linear systems. That's probably a lot nicer, okay? But that's it. See, it's not too bad. Just take it slow, take it step by step, stay organized, stay detailed, pay attention to what you're adding, subtracting, multiplying, dividing, so you don't make a boneheaded mistake and blow up your whole problem, okay? I hope this video was helpful. If you have questions, please let me know. In the next couple of videos, we're going to be covering the applications of 3 variable systems. So stay tuned for that, and I look forward to seeing you guys in the next video.